Yeah, I'm stalling to answer your question. Because, I mean, I typically like to cover section 5.5. I just don't know if I can get that far. Which is your first sophisticated technique of integrating, whatever integrating is.
I think this final is going to be hard enough without you covering new material.
You guys, there's 2.5 weeks left. There's plenty of time.
Time is relative.
What is time?
We have one exam before the final?
No, that's it. We're done with exams.
What's the exact date of the final?
22nd.
22nd. Is it better?
The last week.
Yeah, 3 weeks from today, I think.
Dude, I'm gonna die.
Well, actually, it's 2 weeks from this upcoming Wednesday, isn't it?
Yeah.
I'm just gonna start sleeping in the math center.
Yeah, I'll be in
Yeah.
there in all my spare time.
That is nuts. I don't know if you guys are aware of this. Like every other institution, up to recently, we had a finals week. We just don't have one anymore, so.
So it's just,
What?
so what is it?
It's just whatever the president decides.
The last week is just a regular week class. If the professor gives a final, he or she gives a final, period. Whereas it used to be in the past that the whole last week, you don't go to class, except for one day to take your final exam. Yeah, most institutions work that way. It's just at Sierra College, it's the faculty who got together and voted out finals week. And so really what happened several years ago, it was a math science departments against every other department. Because all the other departments were saying, we don't use it, we just have our students turn in papers, and so we don't want it anymore. Well, now that we've gotten rid of it, I have all these students come and tell me, well, even now for the last week, we just go and turn papers, like it defeats the purpose. Yeah, so it really hurts you, or the science and math students, so we don't have finals.
How's it detrimental to removing the finals week for us?
Yeah. I think the fact that you don't have a finals week is awful, because we're studying material all through the last week,
Oh, I see what you're saying.
as opposed to relaxing, just getting rid of it.
So there's gonna be material that we're learning in the next 2 weeks that are gonna be on the final, right?
Oh, absolutely.
So how many more sections should we anticipate?
Are we stopping at?
About 5, maybe.
How long is the final?
Most of the sections are light. It doesn't really mean.
How long is the final gonna be?
I typically write it for just a little bit longer than a regular exam.
Okay.
Typically.
What section is this an example of?
I have no clue. Whatever L'Hopital's rule is at 4.7.
4.7, okay.
So you guys, how do we evaluate this limit?
Well, you want to do L'Hopital, so you want f of x and g of x, and
Well, yeah, but do you want to know why?
Yes.
Can't you just multiply the top and the bottom by x squared?
By what?
1 over
One
x
over x
squared.
squared.
Perfectly put. So if I dive in and multiply top and bottom 1 over x squared, isn't this our old technique? This now gives me the limit as x increases up bound. Just a 2 plus 3 over x minus a 5 over x squared all over. And 3 plus 4 over x minus 7 over x squared. It's just now when I value the limit, don't these 4 terms, here, here, and here, just simply go to 0.
Yes.
And I think at the end, I'm merely left with the ratio of 2 to 3, 2/3. If you were to try to graph the equation y equals all this garbage, I think y equals 2/3 would be the location of the horizontal asymptote, and this is why.
You said that doing the whole negligible thing was kind of Harry Potter-ish, right? Which was the one where I said 3x and 4x can technically be considered negligible because it's x squared, so it's approaching infinity faster, so you can just look at it that way.
Yeah, you really can't. I just hate to say it with such hand waving.
Yeah.
I mean, I just want to be
That's
more
what I'm
precise.
Yeah.
As a matter of fact, my new technique, L'Hopital's rule. L'Hopital's rule basically says this. To differentiate this limit, I can simply come in, and instead of dividing the limit directly, I will simply dive in and take a peek at the limit of the ratio of the individual derivatives. Don't take this the wrong way. I'm not somehow avoiding or doing something different than the quotient rule. This isn't a quotient rule application. I'm merely saying that the limit of a ratio of one function to another if it's in one of my indeterminate forms, 0 to 0, or infinity over infinity, it's one of the ladders, then I can apply L'Hopital's rule, which says I differentiate my numerator, and I differentiate my denominator. Oh shoot, it doesn't work. I still get infinity over infinity.
So, what is the advantage of L'Hopital's rules? Because it seems like I understand these are elementary examples, but
Yeah.
it took you one step and you solved it, and in L'Hopital rules sometimes you have to go 3 or 4 steps.
I know, but you know, when I introduced L'Hopital's rule, I really do like to go back to a limit I can evaluate before, so you see you get the same answer. But I promise you, with most of my examples tonight, they will not be questions we could answer previously.
Gotcha.
I really will muck up my examples. You guys, I failed. I failed to use L'Hopital, I misspoke. I failed to have L'Hopital's rule get me out of this indeterminate form. I still got infinity over infinity situation, so what do you want to do?
Differentiate
Do it
again.
again. And do it again, unless the limit, as x places gain, of the ratio of 4 to 6. But jeepers, that is just 2/3, it's the same answer I got before. Guys, I'm afraid at this stage of the game, I'm going to have to say that when I read my own work, I'm getting a headache. I don't want to think that much when I'm reading your work. So I need you guys to tell me somehow that you're using L'Hopital's rule. Since I use L'Hopital's rule from here to here, I have a tendency to put a circle around my equal sign. So you, the reader, clearly understand I applied L'Hopital's rule. I'll do the same thing down here. Maybe you don't. Maybe some people out there just write LH for L'Hopital's rule. Instead of circling the equal sign, you do whatever you like. Just show me, the reader, that you applied L'Hopital's rule.
So we were going over examples of this before class, and when would you want to stop using it? So say the second time.
Whenever you get out of the loop of having a 0 over 0 situation or infinity over infinity situation, and Becky, that's exactly what happened to me here. I applied L'Hopital's rule the second time around, but here I've got a 4 over 6, it's not infinity over infinity, it's not 0 over 0.
Is there ever a situation where it can just keep going 0, 0?
Oh yes, and then you will have to find some other techniques.
So how do you identify those situations? Yeah.
Oh, you'll know, because this will be like a square root, then the 3 has power, then to the 5 has power. You know you're not going to get out of that loop. You will see just things escalating in their nature, and you will naturally see that you want to stop the process.
What if it's stressed out on the test kind of deal, and you don't actually see anything?
Well, then when you run out of room on your page.
Like, what if there actually is an answer like 20 derivatives down? Like, do you actually?
Oh, you'll be able to see. You'll be able to see.
Okay.
That you can differentiate.
Okay.
Repeat and end the process.
Solid guy wouldn't do that.
No.
Nobody's laughing.
Because somebody mentioned it.
Gonna see it sometime.
Oh,
There we go.
So how many times are you going to differentiate?
Infinitely many.
I can't hear.
Infinitely
I can't hear you.
none.
None.
No, I can hear you.
No.
It's a finite number. It's a finite number.
N time?
Thank you. And after applying L'Hopital's rule n times, what do you get? Yes.
N factorial over e to the x.
And what does that limit value to?
A lot.
Isn't that n factorial over a small number?
N factorial
Oh,
rule.
over a really big number.
Therefore.
Zero.
Zero.
Very nice. Do you guys agree?
Yes.
Quiz extra credit, write it down.
Ooh, you guys remember this one? Do you remember in class it took me 20 minutes to value this limit? I had a very long geometric argument and ended up using a squeeze theorem.
Yep.
But I think we don't have to do that anymore. I think we can answer this question in one step. Because I think when I plug 0 in for x, I get a 0 divided by 0 situation. That means I can apply L'Hopital's rule. And applying L'Hopital's rule, I think this is equivalent to the limit, as x plays this game, of the derivative sign of x to the derivative of x. But now when I apply L'Hopital's rule again, you guys humor me with this. What can you possibly say about the derivative of the cosine of x?
You don't need to.
I don't wanna hear I don't need to, I wanna hear can
Why
I?
can't you just plug in zero?
Why can't I do what I'm doing?
You don't have to.
What's that? Well, that's not my question, my question is why can't I?
Sure, you can.
Well,
Because it's not,
the-
it's not an indeterminate form.
Yeah, and the derivative of 1 is 0, so it
Yeah.
just
Well,
screws
not
that
even
over.
that, I just think at this stage of the game, this is not a 0-0 situation, it's not
Yeah.
infinity over infinity situation. I have no mathematical legal right to apply L'Hopital's rule. So I guess I better just take a break and see if I can't divide the limit. Well, as x goes to 0, what does the cosine of x do?
1.
It goes to 1, and so I think I'm just left with 1.
It's too easy.
Oh, I know.
Maybe it stays.
So that EMC squared. Oh, whoa. Is that an N?
Alright, that's better.
Yeah, I thought so. Yeah, wait.
No, it isn't.
It could be in.
Whoa, hold it.
It's
you
not
guys.
0
You're
over 0.
right, I'm so sorry. Okay, that's right.
Hey, you shouldn't say anything.
Is it a 0 over 0 situation?
Yes.
Yeah, I think it is. So let's apply L'Hopital's rule. You know, my old tricks certainly don't apply here. And applying L'Hopital's rule, that gives me the limit as x plays this game of
Negative sine x plus 2e to the minus 2
all over.
Wait,
2x.
Now, what does that evaluate?
that wouldn't be a 0 over 0 situation.
Which one would it be?
Well, because e to the 0 is 1,
Mm-hmm.
so it'd be 1 over 0.
So 1 plus 1.
Oh, yeah, 2 over 0.
Man, did I goof this up again?
Yeah. It should be a minus. It should be cosine of x minus e to the 2x.
I know, but I was doing it ahead, and
Yeah.
I wanted it to apply twice.
That's 2 wrongs just today.
It's 2 wrongs just today. It's 2 wrongs. 2 minutes. Hold on. I want this to work beautifully. Alright.
Reminds me of a joke.
You got the little problem.
Iron Man in the back.
Ah, the heck with it.
And Iron Man sitting like that thinking about the chess piece. What is
It's just shake. I apologize.
Now I'm just trying to make the win so it can spell my name.
Now you reach the 0, 0, 0.
I'm trying to arrange the pieces.
So you guys, is helping?
Yes.
Are we done?
What?
No, I don't think I'm done. I think I'm still in trouble.
I don't know
Because
if
now
I get that.
when I value this limit of x is 0, I still get a 0 over 0 situation. What do you want me to do? Apply it again. And applying L'Hopital's rule again, now I'm left with an equivalent limit of actually, I have no idea. Negative cosine of x plus 4e to the 2x all over. But you know, the denominator is just a constant. I'm guaranteed this is not going to be another application of L'Hopital's rule. So let's just deal with it. Let's see if I can just get lucky and have get an expression or a number when I plug 0 in for x. And you know what I think I do? I think that gives me a, is that a positive 3x? So everybody, some standard indeterminate forms. If I have a 0 over 0 situation or an infinity over infinity situation, that's when I can apply L'Hopital's rule. What happened?
Isn't there a negative infinity in there as well?
You know, infinity's negative infinity, that's
Oh,
fine.
it doesn't.
However, I think 0 times infinity, or infinity times 0, is another indeterminate form. Perhaps not one for which I can apply L'Hopital's rule, but I still think it's an indeterminate form. You guys, let me backtrack. I feel like I'm talking too fast. I feel like I'm beating that clock, and I shouldn't be doing this. The reason why, this is what I mentioned last time in class, that these two are what I refer to as an indeterminate form is because it's a race, it's a battle. If my numerator is going to zero much more rapidly than my denominator, I think the whole fraction goes to zero. I think if the numerator goes to zero much less rapidly than the denominator, I think that fraction go to infinity, or maybe something in between happens. But same thing with infinity over infinity situation. I just think this should be considered another indeterminate form for this reason. My first factor goes to zero much more rapidly than my second factor goes to infinity. I think the whole product is probably going to go to zero. However, if my second factor goes to infinity much more quickly than my first factor goes to zero, I think the whole thing goes to infinity. Or again, maybe something in between happens. So, I think this deserves for me to take a peek. Oh, I lost my count. Am I at number 5? Okay, you guys, I give up making examples up out of thin air and messing them up. How about something like e to the negative x times x cubed? If I take the limit as x increases that bound. Do you guys agree in this example, this certainly is a 0 times infinity situation? Because when I plug, whoops, hold on. That was a negative. Because when I allow x to increase that bound,
It goes to 0.
I think the e to that power is going to go to 0. But this one's going to increase that bound. I think it is an example of my second type of indeterminate form. So the way I take care of this type of indeterminate form is I rewrite. I mean, if I've got the limit of f of x times g of x as x plays whatever game is playing, and it's a 0 times infinity situation, I will either rewrite this as a limit as x plays this game of the ratio of f of x to the reciprocal of g of x, or the ratio of g of x to the reciprocal of f of x, and this is going to put me into one of my first 2 types of indeterminate forms, either 0 over 0 or infinity over infinity, for which I can apply L'Hopital's rule.
Is that an A? Or
Yeah, it is an A. So no matter what A is, even if it's this, it still works. Well, you guys, let's do it over here. In this particular example, I will rewrite this as a limit, as x plays this game, of the ratio of x cubed to an e to the x. You guys, here's a nice example where if you did it the other way around, that would be an infinite loop. It would never stop the process. Now, I maintain that I'm trying to value this limit. This really is an infinity over infinity situation. L'Hopital's rule applies. And if L'Hopital's rule applies, let's deal with it.
Isn't that negative EPX though, Ron?
Well, no, because e to the negative x here. And so if I reciprocate that, 1 over e to the negative x is going to be e to the x. But doesn't that leave me with this? Am I done? No, I've got to apply L'Hopital's rule again. And applying L'Hopital's rule again, I guess that gives me the limit. As x increases with that bound of the ratio of 6x to e to the x, what's up next?
Do it again.
Do it one more time. Applying L'Hopital's rule one last time, that leaves me with the limit, as x plays this game, of the ratio of 6 to e to the x. But you know what? I can deal with that. That's simply going to give me
0.
I agree. Because my numerator is fixed, and my denominator is increasing without bound. Ooh, this looks fun. What was that?
My lighting has been off on this thing all day. Yeah, it normally auto adjusts, but it got really bright for some reason. There we go.
I don't know, you guys. Do you think this is a 0 times infinity situation? Or vice versa? Well, as x goes to infinity, what happens when I sign my first set of parentheses?
Yeah, it
Minus.
just goes to infinity.
Which is just 0. But the second factor increases that bound. So I think it's definitely such a case, isn't it? So, let's rewrite it. No, not applying L'Hopital's rule. I'm just simply rewriting this. I don't know, you guys, what do you want to keep upstairs? What do you want to throw downstairs? So you want that upstairs? Well, now when x increases up, my numerator is going to 0, so my denominator is going to go to 0 as well. I think this is going to be an application for L'Hopital's rule. Yes?
Does it matter which one you put on top of which one?
Oh, I think it makes a big difference. If you give it a shot over here, I think here's where you can apply L'Hopital's rule infinitely many times and never get out of the loop.
Why was it best in that situation to put the natural log on the bottom?
I don't know, I just asked somebody. Somebody said,
Oh,
keep the inverse tangent upstairs. And in applying L'Hopital's rule,
is there a way to stop and kind of like try and evaluate in our heads beforehand to see which way?
you know, a lot of times you really can't. You can just simply analyze what the benefit is to have one of these downstairs.
Will it work either way, but one way's better, or will it just not?
Quite the contrary. Like I was saying, this is a great example where if you threw this factor downstairs, you would be applying L'Hopital's rule repeatedly. It would never get you out of the loop. Think about it. You'd have a 1 over x cubed downstairs. That's x to the negative 3 power. But when you differentiate x to negative 3, the exponent becomes negative 4, then negative 5, then negative 6, and your numerator is always going to stay as e to the negative x with a sign change out front. It would never stop. Well, let's see if it works. Differentiate my numerator. I said differentiate my numerator.
Just 1 over square root of
1 plus.
square root.
Nice, 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 nice. Can you read that? What's the next word? What about downstairs?
Yeah.
1 over x, so it's x.
1
1 over 1x, so that would be 1 over x.
Oh, you guys. Negative 1 over
X squared.
x,
What?
natural log square root of x? Did I walk in the right room? Sure. How about this? Then differentiate, bring the exponent down. Oh, there it is. Reduce the exponent by 1. Oh, there it is. And chain rule says multiply by the derivative of what you're raising to the negative 1 power. Oh, there it is. Cheapers and cheapers. And so, I think in the end, that's going to give me the limit. As x plays this game, you guys, I really do need to take a break and just clean this mess up. Does that give me a negative x natural log square root of x over 1 plus x squared?
So, does this only work for 0 times infinity, or say you had an original equation that was like 0 over infinity or something like that, or
0 over
infinity?
infinity, I would not consider it indeterminate form because that
Okay.
means the numerator's going to 0, your denominator's increases that bound. I think that ratio would have to go to 0.
Okay.
That's not a standard indeterminate form at all. You guys, what's next? Evaluate it. I just tried it.
See if it's indeterminate.
I just did it is. So, L'Hopital's rule again. And applying L'Hopital's rule. Upstairs, I'll use the as well as the chain rule. And I've got the first as is, don't touch. Times the root of the second. Plus the root of the first. Times the second as is. All over the root downstairs. But that's merely going to give me, if you guys allow me to clean up a tad bit, the limit as x increases that bound. Instead of negative 2 natural log of x minus natural log squared of x, all over 2x. Yeah, I'm still getting an infinity over infinity situation, aren't I? So, applying L'Hopital's rule one more time. That gives me the limit as x plays this game. The ratio of something to 2, that's nice and clean downstairs. However, my numerator ends up being negative 2 over x. Is that a minus 2 natural log of x over x? More cleanup time. Does that give me the limit? As x increase that bound? Of the ratio of, you guys, I really don't know. Is that a -1 minus natural log of x over x?
Yes, it does.
Yeah, shoot, still the darn standard indeterminate form. Let's do it again. Is that gonna give me -1 over x, all over 1? Oh, but shoot, that's just a negative limit as x plays its game of a 1 over x. What does that do as x increases that bound? Goes to
0.
nice. I was able to value the limit. All that for 0. 0 is a very special number of mathematics.
It breaks math.
It breaks math?
Yeah, you can't divide by it.
That's true.
There's zeroth law in physics.
There's a lot of things that break math, like sledgehammers.
You don't want to try that at home.
Calculators all the time. Rooftops.
Science.
Do you guys think this should be considered an indeterminate form? Do you think this should be considered a race? I was hoping intuitively you say yes.
But it wasn't a yes or no.
Oh, no, I did. I asked, do you think this should be an indeterminate form?
Or should it be a race? I don't know what you said.
I mean, the same thing though.
Oh.
Same thing.
So we consider that same thing between 0 times infinity, then
Maybe not quite the same, but I think it should be considered a race because I think of my first function. If it's increased without bound much more rapidly than the second function, then I think this whole thing's going to go to infinity. If this one increased that bound much more rapidly than this one, I think the difference goes to negative infinity, or maybe anything in between infinity and negative infinity, because I don't know which one's greater value. So, everybody, I think I should consider a third indeterminate form. For example, taking a peek at something like the limit. Actually, I don't know. I don't want to make one up. These I can really goof up easily if I make one up off the top of my head. How about 1 over? The natural log of x plus 1. Minus 1 over x. As x approaches 0 from the right-hand side.
well, that's charming.
Any ideas?
Just quit and go to the next one.
Couldn't look at the next one. Is that what you do in an exam situation?
Apparently,
Yeah,
because
0 over 0.
Anybody?
simplify.
Infinity minus infinity.
Math D.
Isn't it the same?
It's
one
definitely
that
one of these.
Dude did before. You have to simplify it. Put it into one fraction.
Got it. You guys, the reason why I'm stalling and I'm not saying anything is because when it comes to infinity minus infinity situation, I don't know if I can just come here and declare, oh, there's one way to do it. There's various different tricks you can apply, but I think what's natural here is just simply combine them to a single fraction.
I was gonna say, can you do it as a natural log x times natural log of 2? Like a that.
Yeah, unfortunately not. I can't split up addition on the inside. But I can write this as a single fraction. Yeah, then what?
Differentiate?
Well, is this an indeterminate form?
Yes.
Yeah, I still think I get a 0 over 0 situation. And since it's still an indeterminate form, I think I can apply L'Hopital's rule. And in applying L'Hopital's rule, I think that gives me the limit. As x approaches 0 from the right-hand side, of the ratio of, actually, I really don't know. Is that a 1 minus 1 over x plus 1?
Yes.
All over x plus 1. Plus the natural log of x plus 1. Now, you guys, I'm going to be completely honest. I don't know what happens next. I really don't. Upstairs, I get 1 minus 1, which is 0. Downstairs, however, I get a 0 plus, oh, look at that, another 0. So what do we do?
Again,
I'm tired.
combine my fractions.
Or just clean up.
Yeah.
How about using our math skills to clean up this mess? I got a big fraction which are smaller fractions embedded. Let's you and I multiply top and bottom of the big fraction by the quantity x plus 1. And I think that's going to leave me with a limit as x plays its game of the ratio of an x to an x plus 1 times the natural log of x plus 1. Ooh, you guys, it's time to take another breather. Now that I've paid the consequence of my actions, I clean this mess up algebraically. Let's see if I can evaluate the limit. Oh, shoot, I can't. It's still a 0-0 situation. So, let's play with this house one more time. Does that give you the limit? We're upstairs, I'm left with a positive 1. Downstairs, I'm left with a 1 plus, oh shoot, I gotta slow down. Differentiating the second term requires me to use the product rule. But you guys, the first times the the second is just simply 1 plus the second times the first. Is this working?
Yes.
Hugely. Because now I think I'm
You
really
just have 1 over 2.
Where did I get it?
The
1 half?
natural
We'll plug
log
the
of
0 for
1 is
x.
0.
1 over 1 plus 1 plus 0. Is it really?
Yeah, the YouTube teacher taught us this exact same one before class.
You're kidding.
I'm
Wow.
not. It's the exact
funny.
same problem.
I did it at home. Make up my own example.
It's really close. It's the same.
You know, you guys, I have to confess, I can't sit down and think of a lot of examples where I've got an infinity minus infinity situation. I'm pretty darn limited, I think. Well, you guys, if you're okay with that, how about the real big guns?
Yep.
I think this should be considered an determinant law. I mean, in other words, if I got the limit of something like this, where f of x is going to 0, but g of x is going to 0 as well, I think this should be considered an indeterminate form for this reason. If this base is going to 0 much more rapidly than the exponent, I think the whole thing should go to 0. But you know, if this exponent is going to 0 much more rapidly than the base, I think the whole thing should go to 1. I think it's a race. Infinity situation, I wouldn't call it indeterminate form, because I think it's always going to infinity. But maybe something like 1 to the infinity power. Or maybe something like infinity to the 0 power. I think all three of those should be considered a whole new indeterminate form. And shoot, I need a way of dealing with that. Well, you guys humor me. Number 8. As x increases without bounds, certainly the base is going to 1. And as x is increasing without bounds, certainly the exponent is increasing without bound. I do think this is a 1 to the infinity power situation. Now, the way I tackle such a situation is I simply consider the expression I'm taking the limit of, and I give it a name. Because the variable x is both in the exponential position and the base position, I dive in and I logarithmic. Take the log of both sides. Since I'm the one taking the log of both sides, I have a mathematical legal right to choose whatever darn base I want. I will choose base e because it's easy to differentiate. Now the reason why taking the log of both sides is really handy to do is because of that one wonderful property that allows me to wrap my fingers around the 3x, pull down to the level of everything else by multiplication. Give me the natural log of y being equal to the product of these two beasts. And if you guys try to take the limit of the right-hand side as x increases that bound, don't you get an infinity times 0 situation? And if I get an infinity times 0 situation, then I think that if I take the log as x increases that bound of 3x times the natural log of this nasty business, then I'll simply rewrite this as a limit as x increases without bound. How about the second factor divided by the reciprocal of the first factor? It's perfectly legal if you invert and multiply. Don't I get what it started with?
Where'd the 3 go?
Okay, so maybe the 3 magically disappeared, but since it's just a constant, so I don't have to deal with it, I'm just going to pull it out for it. Because I can. Now, when you try to value this limit, you really do get a 0 over 0 situation. I trust you in the mathematical legal right to apply L'Hopital's rule. And applying L'Hopital's rule, I got the limit as x plays this game. Well, let's see, the derivative of the top is going to be 1 over 1 plus 2 over x. Did I forget anything?
The 2?
Chain rule.
Chain rule. I think I need to multiply this by the derivative of what I was taking the natural log of. Wouldn't that be this? Sorry.
Oh yeah, that's right.
But if I differentiate my denominator, don't I get this? Do you guys see why I'm using my red pen? Just happen to have 2 like factors upstairs and downstairs. Let me slash them. And I think what I'm really left with then is nothing more than 6 times the limit as x plays its game of, actually, I don't know what I have left over. Is that a 1 over? 1 plus 2 over x. Here too, you guys, I want a yes or no answer. Can I value this lemon piece of cake? I ask, can I value this lemon piece of cake?
1.
Yeah, I can. It's just positive 1. So I think I'm left with a 6. Oh no, you guys, I can't do this. I never answered my question. Not that I made any mistakes, but look at what the heck I just took the limit of. This garbage. So let me come back. I think the original question was this. Can we evaluate this limit? As x increases without bound, I don't remember what it is. 1 plus 2 over x. Raised to the 3x power. But this is nothing more than a limit. As x increases without bound of e raised to the power of the natural log of this stuff. And as I indicated before, just using my basic properties of logarithms, doesn't this give me e raised to the power, which is a product of these 2 bases? You guys, now I'm afraid I'm going to have to do a tad bit of hand waving. I really do. It is the case that if this outermost function is continuous, then the limit of this continuous function evaluated at another function is equivalent to that continuous function evaluated at the limit of this nasty business. Just so you guys, I can finally answer my question. I know exactly how to evaluate this limit. That limit's going to be nothing more than 6. So in the end, I'm merely left with e to the 6th power. David,
What possessed you to put the E there?
to put the...
But, I mean, how did you think to go from that to just sticking an E up there? When you set that equation equal to that, to the other one?
Really?
I don't see it.
So I can rewrite that exponent as a product.
Well, no, I understand that part.
My whole goal was to bring this 3x down.
What about the E?
What about it? Because I think e composed with a natural log function, they just undo each other because they're inverse functions. I get what I started with.
What led you to that logic, though? Why did you want to do that for?
Gosh, I don't know. I've been doing it ever since I was a kid. No, I'm serious. When I was in high school, my first graphing, or my first programming calculator, it couldn't raise 7 to the 8th power. So I just naturally tricked my calculator into doing it by raising e to the natural log of 7 to the 8th power, and then I could bring my 8 down, and my calculator could handle these functions. And so it's just a natural way for me to raise 7 to the 8th power. You don't like that.